The MCAT Podcast, session number 153. A collaboration between the medical school headquarters and Next Step Test Prep, the MCAT Podcast is here to make sure you have the information you need to succeed on your MCAT test day. We all know that the MCAT is one of the biggest hurdles you'll face as a pre-med, and we're here to give you the motivation and information that you need to know to help get you the score you deserve so you can one day call yourself a physician. Welcome to the MCAT Podcast, wherever you are listening right now, jogging, walking the dog, lifting at the gym, driving to school. Actually, if you're driving, don't do what I'm about to suggest. But I want you to take a selfie right now, post it on your Instagram story. Say, this is what I do when I'm listening to the MCAT Podcast, and tag myself, tag Next Step Test Prep. I'm at Medical School HQ. Next Step Test Prep is at Next Step MCAT. Let us know how you are listening. If you're driving, wait till you pull over, wait till you stop. That is my advice. All right, today we have some more high yield stuff, some general chemistry, some electrochemistry for you to maximize your MCAT score. Clara, back for some more MCAT podcasts. I'm loving these high yield topics. I really think they're going to help students get those few extra points and hopefully jump them up into the next bracket of kind of percentiles for their MCAT and hopefully get them that acceptance that they may have otherwise missed. So let's go ahead and continue on this week with some general chemistry and electrochemistry. Now, when I opened this up and I was like, ooh, electrochemistry, you're like, yeah, this one's rough. I love it. What is so hard about electrochemistry, do you think, for students?
Oh, I think it's a combination of things. I think part of it is that it isn't always taught all that well in college classes. So there are all these little things you have to keep in mind. You have to memorize for electrochemistry, like things about oxidation potentials, reduction potentials, like signs, like positive, negative. And there are all these really cool patterns that make it super easy to remember which is which. But a lot of times I feel like when people just learn it, they just think, oh, I have to memorize, like this means positive, this means negative. And it's just really, really easy to get it backwards. So people tend to get really frustrated and intimidated. But I love it because once you have it down, it becomes the easiest thing. So
it's just something that has to kind of connect in your brain. And then it's like, oh, now I get it. It's like when Neo finally sees the Matrix and it's just like, oh, this is easy.
It is. Yeah. Just like that.
I was like that with, and it's funny, I was like that with the NMR spectroscopy. The just like weird random spikes across some graph. And I'm like, oh, I know exactly what that looks like. And I could draw it in like 30 seconds. And we had a test once and you had to stay in the lab for an hour to do the test, which was, I think, 2 or 3 of these NMR spectroscopy graphs or whatever you call them. I forget. And I was done in like 5 minutes. And like, you can't leave. I'm like, but I'm done. And so it's just one of those things that I saw the Matrix, right? I just saw it and I knew it. And I don't know why it clicked with me, but hopefully after going through some of these high yield topics, we'll have this click with some students. Are there any potential like resources out there? Obviously Next Step books and the Next Step course. Is there anything out there potentially that may help with a student with electrochemistry?
That's a really good question. And I think I would say nothing really comes to mind. I would say definitely we made a special effort in our course to really explain electrochemistry as clearly as possible, like especially to speak to a lot of the misconceptions that students have. Like there are these things that like almost everyone gets backwards. And so we'll try to really explain why that is. But you can also if you just look up, there are plenty of free videos too. If you need to look up, free YouTube videos on electrochem. I would emphasize just use any resource you can find to try to get this down and review it often, do practice questions often. And anytime you get it backwards, anytime you miss a question, the more time you spend reviewing it, trying to figure out why, the better.
All righty. Sounds good to me. All right. If you want to follow along, we do have a handout for you today. It's the mcatpodcast.com/153. I'll start here with question 33. Zn, we call that zinc. Let's call that zinc. Is that zinc?
It is.
Right. Let's start with that first. Zinc has an oxidation potential of plus 0.76, while aluminum has an oxidation potential of plus 1.66. Which metal serves as the better oxidizing agent? A, aluminum, because it more readily gives up electrons. B, zinc, because it more readily gives up electrons. C, aluminum 3 plus, because it is more prone to gaining electrons. Or zinc 2 plus, because it is more prone to gaining electrons. Wow. All right. So they couldn't just leave it at A and B. They had to throw in this 3 plus and 2 plus. And so oxidation potential, I believe oxidation. Oh, I know that we had a mnemonic for this. Oxidation is giving up or receiving, and then reduction is giving up or receiving. Oh, man. So let's start with that one. So oxidation is giving up electrons?
It is.
Yes. All right.
Think of it like losing. The mnemonic is usually oil rig, so oxidation is losing. Yeah.
Yes, that is the mnemonic. So oxidation, losing electrons. So, so the higher oxidation potential, I think means that it is easier to give up those electrons. And so I think, so the question would be, it says, which metal serves as the better oxidizing agent? And so unless it's trying to trick me that, oxidizing agent means that it's going to reduce something, which I think it is saying that, isn't it?
It is.
Oh, yes. All right. See, I wasn't tricked. So that's the thing where this is the MCAT 101, right? This is why the MCAT is a reading comprehension test. Because a lot of students, because they're in a hurry, will read this and go, zinc oxidation. I know oxidation, oil rig, giving up electrons. And so they'll go, aluminum is bigger than zinc. That must be aluminum because it more readily gives up electrons. But the question is saying which one is serving as a better oxidizing agent, right?
It is.
And so maybe the answer is still the same, but I have a feeling that it is not. Is it not the same?
It's not the same.
Yeah. Okay. So I'm going down the right path. So, oh man. So we want to reduce something. So we do want to give up those electrons to something else. I don't know. I don't know where to go from there. I don't know if that thought process was helpful, but I don't know where to go from there.
Okay, so totally. No, it was. Let me just clarify, because it's so easy to get all tangled up in words here. But just to sort of summarize, you're totally right that it first talks about oxidation potential. Oxidation potential is oil rig, so oxidation is losing. So oxidation potential will be potential to lose electrons. But then we see oxidizing agent, and oxidizing agent means it oxidizes something else. And so that means it reduces. So that's that opposite. You had the idea that there's some sort of opposite thing happening here, and that's what it is.
Okay.
So,
okay.
So that doesn't help, but that is the key. So we're looking for what metal acts to oxidize something else, which metal is best at reducing itself.
Okay. Nice. So that's where the trick comes into play. And again, the MCAT's not there to trick you. It's a pretty straight question, but you have to understand what it's asking you.
Exactly.
All right. So let's go through these and help me figure out, because I'm going to pick C and move on.
Well, let's see. So it's not C. I'll give that away.
Oh, okay.
Well, let's work through them. So, better oxidizing agent, we're looking at something that's really good at reducing itself because
Yep.
it oxidizes something else.
Okay.
Then the rig part of oil rig is reduction is gaining. So reduction is gaining electrons.
Mm-hmm.
So we have to have either C or D as our answer because we're looking for something oxidizing agent reduces itself, reducing is gaining, and then C and D both say more prone to gaining electrons.
Mm-hmm.
So then we already know by now our answer is going to be D. But the key here is that, okay, Al in the question, they told us Al has this oxidation potential of plus 1.66. So it had the higher oxidation potential because zinc's was only 0.76.
Mm-hmm.
So Al had the higher oxidation potential. So that means Al is better at oxidizing. But we're looking at what's better at reducing. So
Mm-hmm.
that must be the other one. So that must be zinc. And then our answer has to be D, zinc, because it's more prone to reducing. We can summarize that.
So for this one, the 3+ and 2+ that are part of C and D, are those there just to kind of distract you? Do they mean anything for this question?
You know, they're not. So they aren't just there to distract. So they have a purpose. They're not necessary to know exactly what they mean to answer it because we didn't deal with them at all, and we still got to our answer here. But the reason why there are charges there, and this is actually really important, and a lot of students mess this up. But basically, so if you think about an actual like reduction or oxidation, like half reaction, you might see something like, oh, Al becomes Al3 plus 3 electrons or something. Like one thing on the side, on one side of that reaction is always going to be charged. And another way to think of that, though, is that, okay, in this question, we were looking for the thing that was the best at reducing itself. Al and Zn as metals can't actually reduce themselves because to reduce, they'd have to gain electrons. They'd actually have to become negative. And there's no such thing as negative Al or negative Zn. So the only forms of Al and Zn that can actually reduce are the positive forms. So Al3 plus, Zn2 plus, those can reduce. So really for this question, it's only there because like technically it's accurate with the charges, but it's also important to understand, okay, you can't just say any old Al will reduce because it can't get more negative than just plain old Al.
Because I could see if they were there just to distract and that doesn't really matter, then why wouldn't B be correct as well? Because if you say that zinc more readily gives up electrons, then you would go, yeah, which means that it's also more prone to gaining electrons.
Yeah, well, that would be true.
But it's not true. Yeah,
it's not. Yeah,
true.
because
Darn it.
Al is more readily gives up electrons.
I'm confusing myself as we're going through this. Okay.
No, it's good. There's usually multiple ways to get a question like this right. You know, like you. So it's good to think about all the parts.
Yeah. So, okay. All right. That was a good one. Question 37. Go ahead and take it away.
All right. 37. Nickel cadmium NiCd batteries are rechargeable cells used in products ranging from remote control toys to airplanes. An NiCd battery in the process of discharging is most analogous to what? So A is a half cell, B is an electrolytic cell, C is a galvanic cell, and then D is a non-spontaneous concentration cell.
So batteries, rechargeable cells, a nickel cadmium battery in the process of discharging is most analogous to. So it's discharging, meaning it's being used and giving up its charge. And so you're going to have to know, obviously this is more of that definition. You're going to have to know each of these definitions. What is a half cell? What is an electrolytic cell, galvanic cell, and non-spontaneous concentration cell? And so for me, I don't know what each of these cells are. Obviously, electrolytic to me sounds the most like electricity and something discharging or something. And so I'd probably go with B because it just looks the most right, but that's just guessing.
Yeah, sure. It is all about the definitions here, totally. And so B is wrong. But the right answer here is C, and it was a good guess, actually, because the difference between electrolytic and galvanic is actually super close. It actually totally depends on, in this case, whether they're talking about a battery that's discharging or a battery that's recharging. Because if you actually understand the difference between electrolytic and galvanic cells, and this is a really fundamental difference in electrochemistry, it's super simple. So an electrolytic cell is one that's non-spontaneous. So it's one that we're like putting a lot of power in to drive the reaction. Whereas a galvanic cell is one that is spontaneous. So it's just running by itself because it is spontaneous. It's producing this electricity essentially in a spontaneous fashion. So when you say a battery is discharging, I like to think of it like, it built up all of this sort of differential basically, and it's spontaneously letting that energy go. So a battery in the process of discharging is always going to be most similar to a galvanic cell, which is an electrochemical cell that's just like letting its spontaneous process go.
Okay. All right.
Yeah.
And then let's talk about the other ones here, half cell and non-spontaneous concentration cell.
Totally. Half cell is just a distractor here. Any electrochemical cell will be made up of two parts, essentially. There's the part that has the cathode, and there's the part that has the anode, to put it really broadly. And a half cell is just one of those parts. So kind of like a half reaction, if you ever see that. A half reaction is one half of a redox reaction. So a half cell is one half of an electrochemical cell. It's not going to ever be a full battery. A full battery needs both halves.
Okay.
And then a non-spontaneous concentration cell is actually a trick. Concentration cells are totally a thing. They're MCAT relevant. They're basically these galvanic cells that depend on different concentrations of the reactants involved. To put it really simply. But concentration cells are a type of galvanic cell, so they're always spontaneous. So there's not even any such thing as D.
Okay. That's good to know.
Oh, yeah.
All right.
Tricky.
Question 39. A certain electrochemical cell contains a positive cathode. With this in mind, which of these statements is true? A, this cell is galvanic. B, this cell is electrolytic. C, this cell could be either electrolytic or galvanic. We cannot decide from this information alone. Or D, this cell is neither electrolytic nor a galvanic cell. Ooh, all right. So it has a positive cathode. And so we know, I think you just said, right? These cells have a cathode and anode. The question is a cathode always positive, or is it the anode that's typically positive? And this is just saying the opposite, or is it just stating the obvious that of course it has a positive cathode because all cathodes are positive? I think, if I remember correctly, the cathodes are positive typically. Is that correct or no?
Not always.
Not always. Okay. All right. There we go. So there's part of the thing, and so we're kind of going back to question 37, very similar, the difference between electrolytic potentially and galvanic. And so I don't know. Let's hear your information on how to break this one down.
Totally. And I included this one because this one actually is super relevant to other parts of MCAT science also. But basically, the way I always like to remember is, so there are charges on electrodes. So a cathode can have a charge, an anode can have a charge, and that charge could be positive or it could be negative. So it's tempting to just try to like memorize, what cathodes are positive, what cathodes are negative. But it's a lot easier to just think about what happens in an electrochemical cell in general. So what happens is, if you've ever heard the mnemonic red cat, and ox, you ever heard that one?
I think so.
Yeah, you probably have. It's like it's almost as common as oil rig. So basically, there's all these mnemonics that are used for electrochem. And red cat anox is basically just saying reduction happens at the cathode, oxidation happens at the anode. So that doesn't help us yet. But if we think, okay, reduction happens at the cathode, that's red cat, that means electrons always go towards the cathode because reduction is the gain of electrons, electrons always go toward the cathode because cathode is the site of reduction. So if electrons are going towards the cathode, and the cathode in this question is positive, that means that electrons are going in a spontaneous direction because electrons are negative. Negative things love to go towards positive things. So basically, this question stem is just trying to really confusingly describe a spontaneous reaction. And spontaneous means galvanic. It always means galvanic. So the cell must be galvanic because the only cells that are spontaneous are galvanic cells.
Okay.
Electrolytic cells have negative cathodes, and the reason why that's super relevant to other parts of MCAT science is because actually gel electrophoresis and like SDS page, like those techniques that you'll see elsewhere, they use electrochemical cells, so they'll actually have a negative cathode. So that will come up often, and even in like biochem.
Okay. All right, electrochemistry. And so again, for a student, you mentioned earlier before we started, kind of the like once it clicks, it's just there. What is it? Like, when does a student know that it's clicking for them?
Totally. So it might seem like there's a lot going on in electrochem, especially just like from these questions. But I think it becomes really clear that it's clicking when you almost immediately can eliminate some answer choices. So like if you actually, even the AAMC has a lot of really good electrochem practice in like their question packs. You'll see if you ever stumble across those later in your prep. And there's this sort of moment when you think, oh, like I see the word spontaneous in the passage, or I see positive cathode in the passage, like right away I can get rid of like two answer choices, because like right away, like, oh, I see this word spontaneous, I can get rid of any answer choice that mentions an electrolytic cell. So that's always really cool. And then the other part is just being able to work through all the steps, right? Because in addition to just being able to eliminate some right away because they're definitionally wrong, there's this sort of moment when you'll be able to like go through all the steps and say, okay, this says oxidation potential, this one is higher, that means the reduction potential is lower, like et cetera, et cetera. And what I always really emphasize doing is before you even get into the like electrochemical cell part of all of this, just learn about redox reactions. Like we have a video on redox reactions in our course. There are a lot of other good sources on them too, but just really make sure you understand, okay, what does a more positive oxidation potential mean? What does a more negative reduction potential mean? And once you get that down, you have what you need to go through the steps. You just have to stay calm and do them.
All right, there you have it. Some more high yield information. If you are looking for some more practice with the MCAT, if you follow Next Step MCAT on their social media channels, they do a free question of the day. So go check them out on social media. Again, Next Step MCAT is where you can find all of their social media. And you can find me at Medical School HQ everywhere on social media as well. I hope you have a great week. We'll see you next time here on the MCAT Podcast.
This is MedEd Media.